Yes, I can.
Thank you.
Okay. So when we talk about trig identities, an identity is just like what something is or what it equals. Let me see if this is working here. Yes. So for example, we have a group of identities called reciprocal identities. And here's an example. That what cosecant is, what its identity is that it's the reciprocal of sine. It's 1 divided by sine. So that's what we would say its identity is. It's also true because of this, and it's important to know, that sine of x also equals 1 over cosecant of x. So they're reciprocals of each other. And that's true with secant and cotangent. Secant is the reciprocal of cosine, but that also means that cosine is the reciprocal of secant. Cotangent is the reciprocal of tangent, and vice versa. Sometimes those get overlooked. Notice for all of these that we're saying, like, we have x in here. We have some sort of variable. Actually, we don't use x that much. We tend to use a variable called theta. Let me see if we have any on here. This is theta. It's just another Greek letter. Usually this is what goes with angles. You might remember from geometry when we did sine, cosine, and tangent, we were always calling the angle theta. So we see that the most common. But we can also see, like, this would be alpha. Sometimes we'll see beta. We'll see different letters. We can see x, y. It doesn't matter. What matters is, pay attention to the variables. If the variables are different, if one of them's alpha and the other one's beta, then that's going to change how we approach this problem. So, get used to seeing different letters, but make sure you can tell when they are different. And we're going to see that more next week, having x and y in the same problem. Okay, so those are the reciprocal identities. We also have these things called quotient identities. So tangent is the same as sine divided by cosine. If you think of the unit circle, which should be really fresh, what is tangent on the unit circle? How do we find tangent? Y over x, right? And on the unit circle, what is y? Sine, yeah. And what is cosine?
X.
Yep. Yeah. So even from the unit circle, we were seeing this, and I probably mentioned it, but tangent can be split up to be sine over cosine. Cotangent is the reciprocal, so it's the reciprocal. But just like from the unit circle, cotangent of theta does equal x over y, which is the same thing. Okay, so what we're going to do today is we're going to use these identities to both simplify trig expressions, but then also do some basic proofs to start. And so here's kind of what that is going to look like. We're going to see some problems like this that say simplify to a single trig expression. And so what I'm going to use here is I'm going to use my identities. So cotangent, I can rewrite that as what? Yeah, cosine over sine, or I could write it as 1 over tangent. Either one is good. Let's go with cosine over sine. We're going to learn that sometimes we might have an idea that works, and sometimes we have an idea that doesn't work. One of our main things is just try something, replace it with something that you know. Secant, we can replace with what? 1 over cosine. And then if we have that sine of u, let's just write that as sine. We might notice that some things are going to happen here. What's going to happen? Yeah. We cancel out cosines, and we cancel out sines. When we cancel everything out like that, what's left over? 1. So this is the kind of thing that's going to be happening in this unit. We're going to have something like this that actually simplifies down to something that you might not have expected. So that whole thing just equals 1. Usually when we're simplifying, the best strategy is to change everything to sine and cosine. Usually. Because everything can be turned into sine and cosine. Tangent and cotangent can also be turned into sine and cosine. So why don't you guys give that a try with number 2. See if you can simplify that. And we'll talk through some different ways of how to do that. Yeah, see if you can get that down to 1 trig expression, yeah. Okay, check in with your neighbor. How far were you able to simplify this? Yeah, no.
I was wondering, so if the denominator is going to end up being a factor, can we just like multiply by reciprocal of that factor? I mean, of that fraction?
Yes. Yep. Okay. So, were you guys able to get this to simplify to 1 single trig expression? What was it? Tangent, yeah. This all simplifies to tangent of alpha. If you got it down to like, I don't know how to draw alpha. Maybe I'll just do A. That's fine. Tangent of alpha. Yeah, right. I know. I'm struggling up here to draw it. My brain's just like, no, don't. Yeah. My hand can't move that way today. If you got it to be sine over cosine, well, what does sine over cosine equal? It equals tangent. So this is when we say simplify it to a single trig expression, that's like a single one. There's a few different ways that we can do this. And so that's what kind of can become fun about this unit, is that there's more than one way. It's kind of like a puzzle. So we're trying to simplify this as much as possible. So one way that we could do this is if I changed everything to sine and cosine. So this becomes 1 over cosine of A, and this is over cosine of A, sine of A. So raise your hand if you did this. Nice, so that's just about everybody. Okay, there's a few different ways we could approach this next, but what could we do on top here?
Cancel out the cosine.
Yeah, cancel out the cosines. So that means we're just left with 1 on top, 1 over cosine of A, sine of A. I'm going to get rid of that line, actually. And then exactly what Mo was saying, we can multiply by the reciprocal, so this equals sine of A over cosine of A, and that is tangent. There's a few other ways we might approach this. Really just one other way. So turn to your neighbor. What will cosine of A times secant of A always equal? And why?
Because it's cosine on top of this. I have a question. Would we be able to write it as, like, instead of writing it as sine, just write x, and then instead of...
No.
Or not x, y? No?
No, because sometimes there's going to be different things inside the parentheses. Yeah.
Okay.
So I always got to write out the whole thing. Yeah, good question. Okay, so cosine times secant, if the angle is the same, it's A for both, always equals what? 1. Yeah, they're reciprocals of each other. One's cosine, one's 1 over cosine. So actually, if you want to add that to your list of identities, I like to. Cosine of x times secant of x equals 1. They're reciprocals. And that's going to be true sine times cosecant and tangent times cotangent, as long as the letter is the same. So sine of x times cosecant of y, that's not going to work. But if the angle is the same, that's what it means to be a reciprocal. It's like saying, what's 2 times 1 over 2? 1. What's 12 times 1 over 12? 1. That's the same idea. Hello? Sometimes I can scribble it out and sometimes I can't. I don't understand it. Okay. That's just a good one to keep track of. Bless you. So if we recognize that, maybe we could start this one off by saying, oh, I see cosine times secant on top. Well, that equals 1. So this is 1 over cotangent of A. And what's 1 over cotangent equal? Tangent. So there's different ways to approach this. Okay, so those are a couple examples of where we're simplifying an expression. Most of what we're going to be doing this unit is going to be this right here, verifying the identity. What are some synonyms for verify? What does verify mean? Solve? We don't verify for x. Prove? Yep. Check? Yep. Prove? Check? Other ones? Yeah, it's like English class, I know. Any other ones?
Revise.
What's that?
Revise.
Revise? No, that's like fixing something. Proving, checking. Any other ones? Show. Demonstrate. Make sure. So, there's something very important that we have to do here. This is the same in geometry too when we do proofs. This is the same too when you're trying to make a logical argument. If you're trying to prove something's true, can you assume that it's true? Can that be part of your argument? Can I say, what's something I might want to prove? If I'm trying to prove the Earth is flat, can I say something like, okay, we all know the Earth is flat, so therefore the Earth must be flat? No. That's called circular reasoning. That's called begging the question, actually. That's the correct usage of beg the question. So what I can't do, I'm trying to prove that these two things are equal. So what I cannot do is assume that both of them are equal. We need to prove it. Now, spoiler alert, they are equal. But I can't act as though they're equal when I'm trying to prove it. What that means is we cannot treat this like an equation that we're going to solve. And really what that means is like we can't do the same thing to both sides. We can't divide both sides by the same thing. We can't multiply both sides by the same thing. We can only do that when two things are equal. And we're trying to prove that something's equal. So all we're allowed to do is simplify on each side. And this is really, really important. Mo.
Is the answer x times y over x equals y? Like,
That is basically how we're gonna get to the answer. Yes. Yeah. I'm gonna explain how we're gonna do these and what it's gonna look like. But yeah, I'm doing a little bit of setup here first. So, yeah, to illustrate this point here, if I could divide both sides by cosine of x, then I have tangent of x equals sine over cosine. And is that a true statement? That is a true statement. Unfortunately, I'm not allowed to do this because I don't know that those two things are equal. So I don't know that I can divide both sides by the same thing. If I do that, if I do the same thing to both sides, you get no points for this because you're basically not proving what you're supposed to be proving. You're assuming that it's true. So that's definitely not allowed. But we can simplify both sides separately. So when you do this, you always want to work vertically. And honestly, throw back to Algebra 1. You know, when your teacher first taught you about solving equations, you drew this line down the middle so you can keep the two sides separate. Let's do it in pre-calculus, but now it means do not cross this line ever. Do not move things from side to side. Treat it as a barrier between the two halves of the equations. You don't have to do that, but maybe it's just a strategy that will be helpful to remind you. We could rewrite tangent of x to be what? Sine over cosine. Yeah. And now what could happen on the left side? Yeah, the cosines cancel out, exactly. And so we're left with sine of x equals sine of x. Once the two sides match each other, then we're done with the proof. So that was a lot of explanation for something that wasn't that complicated, but this is basically how we have to do all of these. So I want you guys to give that a try with number 4. See if you can get those two sides to match by simplifying. There's more than one way to do it. Looks like you guys are getting the hang of this, which is great. There's a few ways that we can do this. what's something that we could do first? What could be a good first step?
Expressing sine cosine.
Yeah, and yeah, Fanny, what were you going to say?
Turn cotangent into cosine and sine.
Yeah. Secant is 1 over cosine. And if we want to do that on the other side, we can too. This would be 1 over sine. Okay. We see cosine's going to cancel out. We're left with 1 over sine equals 1 over sine. Now, raise your hand if you ended up with 1 over sine equals 1 over sine. Raise your hand if you ended up with cosecant equals cosecant. Okay? Which one's right? Both. Both are correct. The goal is to get the two sides to match without multiplying anything to both sides. So there's more than one way. There's more than one way. Now, as you're doing this, please work vertically, like work straight down. So everything that's left side, make sure you put it underneath the left side. Everything that's right side, put it underneath the right side. This is for me and for you. It's to help us both keep track of your work and make sure that you're doing it right. Because I got to grade these things too. And they get more complicated. So just keep that equal sign right in the middle, work vertically. Once they match, you're done. A couple things to watch out for. If there's theta up there, make sure theta is in all of your writing. Every single trig function needs to have a variable. It can't just be empty. It's got to be sine of theta, cosine of theta, secant theta. You cannot replace sine with y and cosine with x like we're doing the unit circle because we're going to have different variables inside instead of just theta. So just write, you got to write out the whole thing. It's a little bit of writing, it's okay. Still less writing than English class. So, yeah. Okay. As these things get more complicated, it's going to be important that we keep in mind some strategies, and there's more than one way to do these, and that's okay. Sometimes there's one really efficient way, and you're not thinking of it, and that's all right. But here are some tips. This is one I've said already. Turn everything to sine and cosine. Sometimes we're going to see some factoring, some multiplying. And keep the other side in mind. What this means is basically like you're trying to get one side to match the other. So it might not be super helpful in number 5 if I found a way to turn this into like cotangent and cosecant, because that's not what's on the other side. What's on the other side is secant and tangent. Now, I'm not saying that's not even possible in this one, but just remember that you have a goal, and the goal is to get the two sides to match. So, with your neighbor, work on 5 and 6. See if you can get those two sides to match. Some of you guys are working on it already. All right, let's check these, you guys. So, it's okay. What always happens with this unit is some people, it clicks with them right away. Some people, it takes a little bit extra time. So it's okay if it's taking a little bit longer. That was me. In high school, it took me forever to get this. Actually, I never got it until I had to teach it. That's true. But if you're struggling with this, just like take a look at the different strategies that we're using. Actually, the number one strategy here is basically try anything. So you just like literally just put your pencil down and replace something with something that you know. Just do something. If you sit and stare at this, it's just not going to work. Sometimes a proof might be 7, 8, 10 steps. You've got no idea how you're going to get there, but once you do step 1, then you're like, oh, well, I guess I could do this next. Oh, well, I guess I could do this next. Oh, well, I guess I could do this next. But if you just try and figure it out from the beginning, it's going to be really hard. It's going to be impossible. So just try anything. Put that pencil down onto the paper and make some markings that have to do with trig identities. So there's a couple ways to do this. What's one? What could we do with number 5? Shelby, what did you do first?
Choose the mode of cosine and sine.
Okay, so you made secant equal
1 over cosine theta plus sine theta over cosine theta.
Nice. Did you do anything to the left side, or did you just leave it?
I just left it.
Okay. And then what?
Then I just simplified the right side.
Okay, how?
Added them.
Why? How? Say more.
Because the denominators are the same.
Yes. Okay. So we have the same denominator. We can add these two fractions together. It just becomes 1 plus sine over cosine. And now we're done. The two sides match. Nice. Did anybody do this by changing the left side instead of the right side? Yeah, Finney, what'd you do?
I changed it to 1 over cosine equal, or plus sine over cosine equals secant of theta plus tan of theta.
Mm-hmm.
And then secant of theta plus tan of theta equals secant of theta plus tan of theta.
Yes. Nice. So we are allowed to split a fraction. We're allowed to split a numerator. We're not allowed to split a denominator. But if we see addition on top of a fraction here, we can break that up into two fractions added together and replace those. So two different versions here. One is changing the right side into the left side. One's changing the left side into the right side. There's a version where you do one step on each side and they're exactly the same. Where it's like this thing equals that thing. That's okay. They're all right answers. It's up to me to figure out if your answer is correct or not. So I've got to grade a lot of different things, but that's okay. I'm good at it. Questions on number 5? All right. Number 6. What's going on here? What can we do with this one? Mo, you got?
So treat the cotangent as if it's regular tangent, but instead of doing sine over cosine, you put in cosecant over secant of beta for the right side, and then.
Okay, wait. So let's break that up into a couple steps. I like where your head's at. So you're saying because if sine is on the bottom of cotangent, I could write cosecant on the top of the fraction. And since cosine is on the top, I could put it on the bottom as a secant.
Yeah.
Okay,
And
yes.
then switch over to the right side. So 1 over sine of beta is equal to cosecant of beta. And
There.
then 1 over cosine of beta is equal to secant of beta.
Yes. Theta. But yes. Yes. Okay. So this is something that you are allowed to do. You are allowed to move cosine to the other side of a fraction and change it into secants. Because another way that I could write this right here is 1 over cosine. Oh, sorry. That's not true. Cosine times 1 over sine. Cosine is 1 over secant. 1 over sine is cosecant. But we can skip this step right there. If cosine's on top of a fraction, you can move it to the bottom, and it becomes secant. If sine's on the bottom, you can move it to the top, and it becomes cosecant. Did anybody do this one a different way?
I flipped sine and cosine, and then cotangent was also cosine of the sine.
Mm-hmm. Like you dealing with this fraction right there?
Yeah.
Yeah. Yeah, that's like 1 over sine multiplied by the reciprocal. So it's cosine over sine. One thing is don't stop here. Like, is that a true statement? Cosine over sine equals cotangent?
Yeah.
Yes, that's a true statement. Do the two sides exactly match each other?
No.
No. They are equal, yes, but you're not done until the two sides are the same. And either version is fine. Cosine over sine equals cosine over sine. Cotangent equals cotangent. Tomato, tomato. As long as the two sides match. Okay. All right. see what we got going on here. Ooh. Okay, do number 7 and 8 with your neighbor, and then we'll do some fun with algebra. So I'll go over these with you guys here, and I'll show you a couple different ways that you can approach them. In general, if it's still feeling confusing by the end of class today, that's okay. We're gonna spend 2 more classes on stuff like this. It's gonna get harder, but basically we're gonna learn like 1 more theorem and some variations, and then just do like a whole bunch of practice for the next 2 classes. So with 7 and 8 both have the same thing going on, where we can distribute something, and that is something just to be on the lookout for. Like, if you can distribute, usually that's a good place to start. Just give it a try, see what happens. When we distribute sine in here, we get, I'll just go ahead and zoom in a little more. Whoa. We get sine of theta plus sine times secant of theta. As I compare this to the other side, it looks a lot like the other side. So I know I'm close. If we have secant on top here, we can move it to the bottom of the fraction and make it cosine. And so we have sine over cosine. And that allows us to change it into tangent right there. So this is sine plus tangent. The other one is really, really similar. When we distribute, we get cosecant times cosine plus sine. Sine times cosecant. This we know is 1. Sine times cosecant is 1. This one here, we can move that to the bottom and make it sine. So this is cosine over sine. Which is the same thing as cotangent. This one. So when we see something that we can distribute, it's just good to go ahead and do that. Usually that gets us somewhere. Again, that might not be your final point. You know, as long as your 2 sides match, you're good. Any questions on those 2? Okay. I'll show you a few different ways you can approach these right here. Seemed like you guys were getting these just fine. One way that we can do this one here is I can write this as sine over cosine. And then we can write this as sine times cosine over sine. And we get cosine equals cosine. But another way that we could do this is if we see tangent on the bottom, I could rewrite this as sine times cosine over sine. Like, I'm splitting tangent into sine and cosine, but it's on the bottom, so they're reversed. You can skip straight to that stage. That's okay if you see it. Boom, boom, and then they cancel. If you're not seeing that connection, that's okay. So similarly in number 2, if I see tangent, I could make that sine over cosine. And if I see secant on the bottom, I can move it to the top and make it cosine, like that. That could all be one step. I'm splitting the tangent up, and I'm moving the secant to the top of the fraction. So that then I can cancel out my cosines. Basically, I'm just trying to show you some things that you are allowed to do to make this a little bit shorter here. This one we saw already. Cosine times secant is 1. 1 over tangent is cotangent. I can just change the other side there. So that's just 1. So this one here, I'm going to keep my 1 fraction. I'm going to change that to cosine over sine. I'm going to take this one and move it to the bottom and make it cosine. I'm going to take this one, move it to the top, and make it sine. And notice I just kind of kept one fraction the whole time. And so now I see, oh, well, everything cancels. We're going to come back to this paper next class. We need to learn our other theorem before we get to those. So just hold on to this. We're going to, don't pack up yet, unless you're going to Academy. What I want to show you guys is we can do a lot of the same algebraic properties here. Homework's on Delta Math. We can do a lot of the same algebraic properties that we can with just regular algebra. So we've seen that we can distribute. We've seen that we can FOIL, all that kind of stuff. So as we're doing this one here, if I distribute that, that's just tangent x, cosecant x, minus tangent x.
Is there anyone?
Delta Math. And then I could look to simplify that just a little bit more. Sine over cosine times 1 over sine minus tangent, and I can see that that would allow me to cancel that out. So probably the most simple version of this would be secant minus tangent. Oops. This is difference of squares. So I want to recognize that this would be sine squared of x minus cosine squared of x. I shouldn't need to FOIL that. I should recognize that that's difference of squares. That's how we write sine of x squared, by the way. I realize that's the first time we're seeing this, actually. Sine squared of x equals sine of x all squared. We just write it with the 2 between the n and the x, so that there's less writing for us. It's the same as sine of x times sine of x. With this, can we distribute the 2 there and make this tangent squared minus 1? Is that right? No. Nope. We need to FOIL that. This is the same as tangent squared, tangent minus 1 times itself. When we FOIL something out like that, it's going to be tangent squared of x minus 2 tangent x plus 1. We're going to see factoring. Hold on, guys. We're going to see factoring in this unit a lot. This one here, we can take out a GCF. We can undistribute. The next one, we can do the same sort of u substitution that we did with natural log. If I make u equal sine of x, then this is u squared minus 4u minus 32. Factor that into u minus 8, u plus 4, and then I just go ahead and substitute sine of x back in for u. So we're going to see a lot of these things start to come together in a lot of different examples.